Here I have the integral of 3 over x squared plus 4 over 3x cubed minus 5 over x dx. Before jumping right into integration, I'm going to think about each term and rewrite it if necessary. So 3 over x squared, in order to apply the power rule, I'm going to rewrite this as 3x to the negative 2. So bring x squared up to the numerator and change the exponent and make it the opposite sign. The next term, 4 over 3x cubed, I'm going to keep the coefficient 4/3 in the front and bring the variable x to the top, and again, the negative 3 exponent will appear because I'm moving x cubed to the other side of the fraction bar. And now for this last term, I have negative 5 over x. So here, the way I'm going to rewrite this is I'm going to keep the coefficient negative 5 in front, and then I'm going to write this still as 1 over x dx, because I do want to remember that this has a special general antiderivative. So let's go ahead and now integrate each term. So here I'm going to have the integral of 3x to the negative 2 is going to be 3x to the negative 1 over negative 1. I'm going to add 1 to the exponent and then divide by that new exponent. Here I'm going to have plus 4/3, and x to the negative 3 will become x to the negative 2 divided by negative 2. Again, add 1 to negative 3 and then divide by that new exponent. And then over here, I'm going to leave the coefficient negative 5, and then I have to remember that the antiderivative of 1 over x is natural log of the absolute value of x plus c. So here, if I decided to rewrite this as 5x to the negative 1, forgetting that the integral of 1 over x becomes natural log of the absolute value of x, I would run into a problem trying to integrate this. So if I attempt to integrate like this using the power rule, I'm going to have 5x to the 0 divided by 0. If I add 1 to negative 1, I get 0. So that doesn't make any sense, so hopefully we would pause at that point and try to remember that the integral of 1 over x is natural log of the absolute value of x. And now let's simplify this a little bit further and rewrite this as negative 3 over x minus, here we can reduce down the 4 and the 2, and we would have 2 over 3x squared minus 5 natural log absolute value of x plus c. Here we have the integral of 6 times the cube root of x minus 4 over the square root of x minus the square root of 2 dx. So once again, before jumping into integration, I'm going to rewrite each term when applicable. So here I'm going to have 6x to the 1/3. I'm going to rewrite the cube root as the exponent 1 over 3. Then here, minus 4 over the square root of x, I'm going to write as minus 4x to the negative 1/2. So the square root becomes the exponent 1 over 2, but it's moving to the other side of the fraction bar, so it'll become negative. And then minus the square root of 2, I don't actually have to rewrite this square root because radical 2 is just a constant. So I'm going to leave that as minus the square root of 2 dx. So now let's apply the power rule here to the first two terms involving x. So if I have 6x to the 1/3, I'm going to leave the 6 in the front. X to the 1/3 is going to become x to the 4/3, and then divided by 4/3. So I'm adding 1 to 1/3. And then the second term is going to be negative 4 times x to the 1/2 divided by 1/2. So adding 1 to negative 1/2 gives me positive 1/2. And then here I have a constant. So the antiderivative of a constant is simply adding the variable, in this case x, after that constant. So it's going to become negative radical 2 times x plus c. Because this is an indefinite integral, so it gets the generic constant for a general antiderivative. And so now it's just a matter of cleaning this up. Now, instead of dividing by 4/3, what I really want to do is think about this as multiplying by 3/4. And in general, I would encourage us to go straight to that. So 6 times 3/4, and then times x to the 4/3, minus 4 times 2/1. So instead of dividing by 1/2, multiply by the reciprocal 2/1, x to the 1/2 minus the square root of 2 times x plus c. So I would recommend us really going to this line right away instead of dividing by a fraction, and then going ahead and simplifying here the coefficients. So here we can reduce down. The 6 and 4 are both divisible by 2. So I'm going to end up with 9/2x to the 4/3 minus here 4 times 2 is 8, x to the 1/2 minus the square root of 2x plus c. And if we prefer to leave our answers similar to the original notation back into radicals, I can rewrite this as 9/2, the cube root of x to the 4th, minus 8, the square root of x, and then minus the square root of 2 times x plus c, making sure to keep this x outside of the square root. So it's square root of 2 times x plus c.